what is the difference between identity and equality? For those of you who may have seen the PyData pub quiz, or who may have seen some of the questions that come up in our intro course, this question of identity versus equality comes up all the time. We have these two operators in Python, the is operator and the double equals operator. And why do we have these? And what does it mean? And what's the value of having these? Well, in the PyData pub quiz and in our intro class, one of the things that we talk about is what's the relationship between these two? Does identity imply equality? Does equality imply identity? And we give people a very simple pop quiz. And the answer to the pop quiz is that two objects are equivalent makes no statement as to whether they're identical. Because you can see here, these two objects are equivalent, but they are not identical. So there's no relationship that you can form in that direction. Similarly, if you look at this example, these two objects are identical, but they're not equivalent. So for something to be identical makes no guarantee of the equivalence. But we often qualify this and say, but an object that's not equal to itself is usually fairly rare. Float nan is a good example of this. Float nan is not equal to anything, not even itself, because it's not a number. It's an error code. And so just like the SQL null, where you have to have some special syntax for saying is null or is not null, you can't say equals null because nothing's equal to null. Well, the nan has the same behavior. There's a very interesting question, which I hope somebody asks me about, which is why is a list of nan values equal to a list of nan values, but a Python ND array of nan values is not equal to a Python ND array of nan values, and why does that make sense? But unfortunately, we don't have time for that very interesting divagation. Instead, let me share with you the remainder of this pop quiz that we give people. It is the case that the is check corresponds directly to the check for identity whether two objects are identical using the is check does correspond to whether their IDs are identical. They're defined in terms of themselves. And so if we extend this to include do these things have the same identifier? Well, the ID being the same is the same thing as it being the same object. Being the same object as ID, they're defined in terms of themselves. And so x is y implies the ID of x equals the ID of y. ID of x equals the ID of y implies x is y. That's always the case. That's a guarantee in Python. That will be the case in every Python interpreter. And for bonus points, we oftentimes ask people about what we can say about x is y, implying the equivalence, implying whether or not the IDs are the same object. And this is actually kind of surprising. In CPython, at least up to the current day, on the current platforms that we use, 64-bit Linux, it is guaranteed to be the case that if x is y, the IDs are not identical. But I'll leave that for you to try and guess why that is. This is a very interesting, and why those qualifications are necessary is very interesting, because this is not the case on IronPython. But that's a story about identity. Why does it matter? What does it all mean? Well, fundamentally, there's a difference between saying x's equals y's and y's equals x's and y's equals x's dot copy. If we're talking about two variables, we're talking about two names, and those names refer to an underlying object. Do those names refer to the same underlying object or not? Where we would see there being a difference is, what if we mutate that underlying object? Will we see that mutation via both names or just via one name? Here we have the case that x's and y's are identical and equivalent. And if we append 4 to x's and we get 1, 2, 3, 4, when we look at y's also has 1, 2, 3, 4 because they're two names referring to the same underlying object. In fact, it is the case that modulo an assignment, that is, as long as there are no additional assignments between when you check them, if two objects are identical, they are always identical for the lifetime of the program. The only thing that can change whether two names register as being identical is an assignment. Whereas equality is a transient property, two things can be equivalent on this line of code, and then 3 lines of code later, something could have changed to one of those objects that wasn't an assignment that makes them non-equivalent. Could be an invisible action, could be something stateful. And so oftentimes when we think about identity, we think of this as a permanent property, and we think of equality as a transient property. Obviously, if you do a reassignment, then you've changed everything up, but for two names with a single unchanging binding, identity is a permanent property and equality is a transient property. Now, why does this matter? This is actually a very deep topic and it matters in many places, some places which we don't have time to talk about. One, the difference between equality and identity matters to understand how assignment actually works and how the scoping in Python works. We don't have time to talk about that in too much depth, but I gave a presentation at PyData Warsaw a couple of years back called Up, Down, Left to Right that talks about all of the mechanics of how scoping works and ties that back to the idea of mutability, immutability, identity, and equality. And we will share that with you when we share the notes from this session. I'll show you a very simple example. Oftentimes you want to update your sys.path. And by the way, I don't know why I got that backwards. You want to update your sys.path and you want to put something at the end of it. And sometimes people say, oh, is that right? Is that wrong? I'm not even sure what's going on here. And they'll do things like say import sys equals sys plus temp. Which one of these is right? Or sys.path equals sys.path plus temp. Which of these is right? And whatnot. Well, this is completely fine. Because what you can think is, this is performing a mutating operation to the underlying path. And this is how Python scoping works. We pass around names or refer to underlying objects, and we can mutate those objects directly if they're mutable objects, and if they're not mutable objects, we can't update them directly. And we can determine whether a mutation will be visible via two names, via the identity versus equality check. Equality just says, do these two objects, if they're the same or not, look the same currently, or are considered equivalent for whatever business use case that we have at hand? And the identity check says, if I mutate it via this name, will it be visible via this name? And so if we were ever curious whether this would actually take, one of the things we could do is we could say, is the path object that I see here the same thing as the path object that I see when I look in the sys module at the parts of the import machinery that looks at this? And if it's the same object, then one mutation to the name in one context will be visible in the other context. Similarly, when we have classes and we pass some data into these classes, this difference between identity and equality and this difference between how all of these mechanisms work will be visible to us. If I pass x's into t and I make an explicit copy, then it's very clear that ad hoc or after the fact changes to x's will not be visible on the object. But if I don't make a copy, then you could pass in some data to an object, and that data, the changes to that data, separate from anything visible that's happening to the object, may happen. And you probably see this all the time when using NumPy and Pandas because it's very unclear when Pandas is giving you a view or a copy. You've seen things like setting with copy warning. It can be ambiguous whether, oh, if I change it over here through this name, through the result of this expression, does it actually change the original thing or not? This is the other reason why this is relevant, because it gives us the beginning of an ability to determine whether something is going to be a live view or a snapshot view. Because if you think about it here, in these cases, I have three subtly different ways to copy this object. Well, the core idea behind this is, am I looking at a live view that changes to the underlying data will be reflected on, or am I looking at a snapshot view? And why I would say that there's no guidance of just always make a copy is, sometimes you want a live view, sometimes you want a snapshot view. And there's actually a very meaningful difference in terms of which of these you choose. This is why this is meaningful. And the last reason why this is meaningful is, clearly this ties very deeply into the idea of value disintermediation, which maybe in a future session we'll talk about in greater depth, because there's a lot of really interesting consequences of taking this approach.